In translating, of course, we're taking those words or sentences and turning them into mathematical statements. Jaden, could you close the back door so we don't have to hear the vacuum? So I'm not going to have you make this full chart because, again, this is something that you guys mostly should know by now, and you don't need to write the whole chart. But if you look at page 14 in your book, you will see a sample chart. And this just goes over, for example, things that, like, if you see the word sum, that you'll replace that with a plus sign. That if you see the word difference, that becomes, in math, a minus or subtraction sign. So it's just kind of a review of that, all the different words. That chart on page 14 has a review of the different kinds of words that you might see and which ones go with which math operations. So let's just try a couple. The trickiest ones, of course, are subtraction. So those are the ones I'm going to focus on for addition, multiplication, and division. Again, look at the chart just as a reminder, but I think you guys know all this already. So let's just try a couple subtraction ones. If I say 3 less than half, let me just say half, of x. Speed that up. 3 less than half of x. So we start to translate it into math. Of course, the word 3 becomes the number 3. Now, x are variable. 3 less than, let's pause and take out the half first, and let's just think 3 less than x. The order in subtraction matters, so that if there's only one way to write this. Would it be 3 minus x or x minus 3? I want 3 less than x. Carissa?
X minus 3.
Yeah, x minus 3. Now that's if it was just x. If I want to say 3 less than half of x, how would I show half of x? Daniel?
1.5.
Oh, not 1 point. No, you could do 0.5. 1.5 would be 1.5, remember, not just a half. So 0.5, you can use a decimal or you can use a fraction. What is going to happen if it's half of x? Diego?
X divided by 2 minus 3.
Okay, you could do x divided by 2. That would cut x in half. Or, if we want to use Daniel's suggestion of a decimal, we could do 0.5 or 1/2. But think about of. Of is usually what, Brian? Multiplication. So we could do 1/2 times x. Here's half of x. You could take half of x by dividing by 2. Or this 1/2 here, we could say 0.5x. There's also half of x. Any of those 3 would be correct, but you can't do 3 minus x. So here's my tip. If you cannot figure out what order to put them in, here's going to be my suggestion. Pick a random number for x. Let's say x was 10, and then let's just solve it. 3 less than half of x. What's half of 10? 5. What's 3 less than that? 2. Right? So what I did was I took half of my 10, and then I subtracted 3 from the 5. So if you pick a number and plug it in and then think, what did I do to get that answer? That will give you, then you just take, here's the random number I picked, replace that with the variable. Let's try a couple more subtraction ones just to make sure everybody's got it. Excuse me. How about a number less than 6? When it says a number, that just means the book is not giving you a specific variable and you can pick whatever letter you want, but it will be a variable. Or it could say x less than 6. Some amount less than 6. Okay? Yeah, here's where it could go this way. Some amount less than 6. Well, if it's less than 6, we're taking that amount away from 6. So whatever that amount is, it would be subtracted from the 6. Okay? How about 8 less than a number. So again, if you get confused and you're not sure, because obviously this is going both ways, where the variable comes first or it comes second, and it has to be in that same position, pick a random number to substitute for the one we don't know, and try it that way. 8 less than a number. What would that look like, Vincent?
X minus 8.
Okay, so x or whatever letter you want, you can choose whatever you want, minus 8. This amount less than what we start with. Again, if I said x was 10, what's 8 less than 10? Well, it's 2. How did we do that? We did 10 minus 8. So I take that 10 that I picked and replace it back with the x. Okay, let me just show you now. So there's a couple subtraction review ones. Let me just show you how we'll kick it up a notch a little bit, is we might just add a little more. Kind of like this one that had multiple operations. We had multiplication and subtraction. Let me give you one more like that. 9 times, right? Sometimes it'll be obvious. Times, oh, that's multiplication, right? 9 times the sum of a number and 3. 9 times the sum of a number and 3. Now let me pause here. What does sum mean? Times obviously is multiplication. Sum, Jim? What about it? Okay, remember it's the answer to an addition problem. And that's going to be important here. Because what I want is 9 times the sum. Meaning, to get the sum, we have to get the answer to the addition problem first. How do I force addition to happen first? Is with parentheses. What's wrong, and you can write this or you can just look, if we did this, this is wrong. This is 9 times x, 9 times a number. And then we just add on plain old 3. This is 9 times the sum. So in order to get the sum first, according to PEMDAS, we would do multiplication first. Unless there's parentheses. The parentheses force the sum to happen first, then we can take 9 times that sum. Does that make sense? You'll also see, instead of sum, it might say, you might see some problems that say the quantity. That also indicates that you're probably going to want parentheses. You're going to get some answer first. Where times, if it was 9 times the difference, you get subtraction first. So there are going to be somewhere without the parentheses it's wrong. So just keep in mind, what am I multiplying 9 by? Am I multiplying it just by a number? No, I multiplied it by the sum or the difference or by a quantity. So that means you do something else first and keep the parentheses. Okay, so that's what you're going to be doing from lesson 1-4. I'll give you 2 pages of work to work on. The next lesson, lesson 1-5, all it does is add in one extra step, is. And you guys already know that, so let me give you an example. Let's say a number, it's going to be a long one, sorry. A number is multiplied by 4, and the result, ooh, I forgot the word when at the beginning, I'm sorry. It won't make sense without the when. When a number is multiplied by 4, and the result is decreased by 6, I told you it was a long one, we're not done, comma, the final result is 10. Now the good news is you won't have to write anything this long. Okay, I'm not going to make you write all these words, you're just going to write the resulting math part. Okay, when a number is multiplied by 4 and the result is decreased by 6, the final result is 10. What? Don't worry, we'll go piece by piece. When a number is multiplied by 4, what's that going to be? Get the door, please. Leanna? Yeah, a variable times 4. You can either do 4x and push them together, or you can do
When you get a
x.
chance, will you sign them? Just sign them, I
Okay,
already,
I can do it right now.
okay, that's fine.
Now, a number is multiplied by 4, and the result of this is decreased by 6. What does decreased by mean? What operation is that, Pammy? Yeah. The result of this is decreased by 6. The final result is 10. When a number is multiplied by 4 and the result of that is decreased by 6, the final result is 10. Now, I wanted to do that one first just to show you. There's 3 is's in there. Only one of them means equals. Is a very common verb, and we need to use it for some things. It won't always be an equal sign. Think of it this way, there's only going to be one equal sign. You're not going to have 3 equal signs. That doesn't make sense. So if you're confused about that, think, okay, where is the final answer going to be? It won't always say final, but that is a clue that that's the final equal sign. Let's try one that's a little bit simpler. Twice the difference of a number and 5 is 11. Twice the difference of a number and 5 is 11. Twice means what? Jane? Times 2, right? Or 2 times something. So let's go ahead and do 2 times. Now, the difference, it's not twice a number, it's not twice 5, twice the difference. What am I going to do, Vincent? What do you think?
Parentheses.
Exactly. Here's where I need to make sure I find twice the difference. Well, I got to find the difference, which means I have to do the subtraction first. And I'm going to force that by putting parentheses. Now notice I didn't put the times sign here. If we just push it up against the parentheses, that is times. If you want to put a times symbol, please use the dot and not an X, because the X looks like the letter X, right? So the difference, okay, of a number and 5. The difference of a number and 5. In this case, it just goes in order. A number and 5. The difference of a number and 5 is 11. Is, in this example, is the equals. If you guys don't need to listen, I can send you back to class. You got all this, Jerome? Okay. Do you have a question? Okay. If the private conversation doesn't end, you'll go back to Mr. Marquez. And if I need to, I'll make a seating chart and put you in front. Okay, so just go slowly. Think about what it says. Okay? Think about the operations and which ones mean what. And be careful if it's got something like this where you're going to need parentheses. And that's it. The only difference between the 2 lessons is that the second one adds an equal sign with a final answer. Okay? So,